What's up, everybody? Good Monday morning. I hope you're all doing well. I don't know why I said Monday morning. And this week is actually going to be kind of a chill week. I'm going to teach you 2 lessons, maybe something towards the end of the week to give you a few points for the week. But other than that, that's it. We're really just gearing up towards next week when we're going to start our final unit of the year, which I'm going to just say this out loud. The final unit of the year is one that, and I'm not saying this from my point of view, from the previous student's point of view, I usually ask for feedback at the end of next unit, and they say it's the favorite unit that they've ever done in their math careers, let alone just this year alone. So we're gearing up towards that right now. I'll let you know when we get there. So arithmetic series, what is that? It's just the sum of a sequence. Hey, you know what? There's going to be times when you are not so much interested in the pattern itself, but the sum of that pattern. Let's just say that, I don't know, somebody's selling something. If they're selling microchips, they're not so much interested in a microchip costing, I don't know, $10 a microchip. They're interested in the cost of a package when, Best Buy buys 400 of those microchips. They are not interested in that one microchip cost $10. They want to know the bill, and the bill is the sum of that pattern of the cost of the microchips. All right, even if they do a little discount, like each microchip is just 10% less than the previous one. All right, that's a pattern. It's actually a geometric pattern, but whoever manufactures the microchips is saying, hey, I don't care about the cost of microchip number 8. I want to know how much it total costs because that's the bill I'm sending them Best Buy. So that's what series are about, adding things up. Now let's get to it. I'm not going to build up the formula for it today. I'm just going to give it to you. Here's the formula right here. N represents the term you're looking for. So if I'm finding the sum of the first 10 terms, N is 10. A sub F represents the first term. A sub L represents the last term. Okay, so the first set of problems are sigma notation problems. Use the sum formula if the series is arithmetic. Use the sum formula if the series is arithmetic. You could find the sum no matter what. But I just basically let you know, if you see any exponents, it's not arithmetic. That's it, done. You don't see exponents, it's arithmetic. Let's get to it. So number 1, hey, that's arithmetic. Number 3, arithmetic. Number 4, arithmetic. Number 2 is not arithmetic, but we could still find the sum. I'm going to do 1, 3, and 4 with you. Okay, so here we go. The sum as n goes from 1 to 20 of 5n minus 2. I'm going to use this sum formula right up here. So I need to know 3 things. I need to know n, I need to know the first term, and I need to know the last term. So n is how many terms there are from 1 up to 20. Well, how many terms are there from 1 to 20? Well, to make it easier, count from 1 to 5. Do it on your fingers. 1, 2, 3, 4, 5. The problem is, if you do the top number minus the bottom number, you're going to be 1 short. 20 minus 1 is 19. But I guarantee you, if you count on your fingers from 1 to 20, you're going to get 20. So specifically with just summation notation, you could subtract the top minus the bottom, but then make sure you add 1 to it. So there's 20 total terms here. I hope you're watching the video, because if you simply look at the worksheet, you're going to go, how did Kalodi get that? First term is the bottom number, and the last term is the top number. That's it. Okay. So let's get to this right here. All right, so let's see here. First term, I'm going to just do 5 times 1 minus 2. So 5 minus 2 is 3. The last term is 20. So I'm going to do 5 times 20 minus 3. 5 times 20 is 100. 100 minus 3 is 97. Okay, the only problem is it's not minus 3, it's minus 2. So let me erase. Oy, oy, oy. Minus 2. And you get 98. There we go. Sorry, everybody. I hope you can forgive me. So then let's just plug in the sum formula. The sum of the first 20 terms is going to be 20 over 2. This is the easiest part about this. Just plug and chug. And then 3 plus 98. I guarantee you that, let's see, 20 divided by 2 is 10. 3 plus 98 is 101. And you get a sum of 1010. Yes, you may use your calculators for this. Let's skip down to number 3, and then we'll go back up to number 2. What is n here? What is the first term here? And what is the last term here? N goes from 0 to 30. So how many terms is that? It's not 30 terms, believe it or not. 30 minus 0 is 30, but then plus 1, there's 31 total terms. If you don't believe me, count on your fingers from 0 to 30. The first term is found by plugging in the bottom number, 0. The last term is found by plugging in the bottom or the top number, 30. Making sure I don't screw up twice. There we go. So 0 plus 6 is 6. And 2 times 30 is 60. 60 plus 6 is 66. So then just plug into the formula. The sum of the first 31 terms is 31 over 2. And then 6 plus 66. If you want to do this strictly on your calculator, go right ahead. 31 over 2. 66 plus 6 is 72. I'm going to just do it a little by hand. Half of 72 is 36. So it's really just 31 times 36. And you get 1,116. You can absolutely just use your calculator for this. Okay, number 2, it's not arithmetic. Doesn't mean you can't find the sum. It just means that you find each individual piece, starting with the bottom number, 2 to the 0, 2 to the first, 2 squared, 2 to the third, and finally 2 to the fourth. 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 to the third is 8, and 2 to the fourth is 16. Add up all these numbers, and you get a sum of 31. Don't forget, the summation symbol means add stuff up. Okay, so I'm going to skip past all the rest of these sums because we just did a bunch of sum problems. Now let's get to a different type of problem. It says the beginning of the series is listed. Find the sum of the first n terms, and they give you n. So in this problem, they're telling you that n is 15. So I need to know 3 things. I need to know n, I need to know first term, and I need to know the last term. Notice that absolutely nothing changes here, but what changes is what they give you. So n, they just give it to you, it's 15. The first term is given to you, it's just 6. That's easy enough. Wow, they're just giving us stuff. But wait a second, what's the last term? The last term in this case is the 15th term. Now there's 2 ways I can get the 15th term. As you can see here, what am I doing? I am subtracting 2 each time, right? So I'm going to write this d equals -2. Remember, d is called the common difference. It's what you're doing each time in the pattern. Now, do they give you the 15th term here? No. There's 2 ways to get the 15th term. I can just keep this pattern going 15 times, or I can use some previous information. Last week's information told us how to find the nth term of an arithmetic sequence. So watch what I can just do. I could just do the first term, which is 6, and then plus d, which is -2, times n minus 1. What's 15 minus 1? 14. And so this becomes 6 minus 28. Do not forget to do multiplication first before addition. Don't do 6 minus 2 first. 6 minus 28 is -22. Hey, I have all the pieces to the puzzle. So then I want to find the sum of the first 15 terms of the sequence. That's just going to be 15 over 2, and then 6 plus a -22, or just 6 minus 22. So then that's 15 over 2 times 6 minus 22, which is what, -16? All right, and I'm just going to cut to the chase here. You're going to get -120 as an answer. That's it. That's it, that's it, that's it. Let's do number 12. I need to know 3 things. I need to know n, I need to know the first term, and I need to know the last term. Oops, I need to know the last term. N is 10, they just give that to us. First term is also just 10, they just give that to us. The last term is going to be the 10th term. So what is the 10th term? Let's just take first term of 10 plus d, which is 10, times n minus 1, which is 9, So that's 10 plus 90, which is 100. I have everything I need now to find the sum of the first 10 terms. Why? Because n is 10. So that's n over 2, 10 over 2, and then times the first term plus the last term. So that's 5 times 110. And so then I work my way through on this now. I have to absolutely stop right here. Can somebody tell me where I screwed up? I absolutely screwed that up because let me write in red here. What is D? D is 7. For those of you who are curious about that, yeah, I just screwed that up. So let me back this up right here. It's going to be, I'm going to do it in red, my fixing here. And I'm going to absolutely fix this. Sorry, everybody. And I'm going to fix this. I'm going to fix this. And so 7 times 9 is 63, plus 1 is 73. So then I'll put 73 right there, and then I'll put 83 right there. And then that gives me a total sum of 415. For those of you who are following along with that video and going, oh man, Mr. Cloda doesn't know what he's talking about. You're right. I messed that up for half a second. Okay. So there we go. You're going to do that same exact process for all these problems. So with that said, I'm going to skip to the next section of problems. Same stuff, same stuff, same stuff, same stuff. All right. Let's say find the sum of the first 50 even numbers. Okay, so let's see here. N, first term, and last term. So what can I do to find? So I know what N is. It's the first 50 even numbers. So N is 50. That's easy enough right there. The first term, what's the first even number? 2. We'll start with the 2. And then the last term. Do I know what the 50th even number is? Well, how do I find even numbers here? So I could just do 2 times 50 and get 100. That would be the 50th even number, would it not? Yeah, 2 times n. And so I am now ready to find the sum of the first 50 numbers. Great. So how do I do that? I do 50 over 2. And then I'll take the first term plus the last term, which is the 50th term in this case. So I get 25 times 102, and I get 2,550. Okay. And so there we go with that. I'm going to let you, we got the rest of those. Let's do one total word problem, and then we'll finish this up. How about if I give you a word problem? Jamie's boss. Jamie's boss has got it. Okay. Jamie's boss makes her deal that she will earn $2 in the first hour at work, $4 for the second hour, 6 for the third hour, and so on. How much money will she earn if she works a 12-hour shift? So then, same information. N equals A sub F equals A sub L equals. So N, it's a 12-hour shift. So N equals 12. First, oh, the first term is easy. What did she earn in the first hour? $2. I need to know how much she earns in the 12th hour. So that's A sub 12. I don't know that, but I could use the nth term formula. Use red for this one. A sub 12. So that's going to be the first term. 2. What's D here? I'm not going to make that mistake again. 2, and 4, and 6. Yeah, D is 2 here. That's fine. I'm not going to make that mistake again. All right, so 2 plus D, which is 2, times N minus 1, which is 11. So 11 times 2 is 22. 22 plus 2 is $24. All right, I got all the pieces I need. Let's find the sum of the first 12 terms. That's going to be 12 over 2, and then 2 plus 24. So that's 6. 12 divided by 2 is 6. 24 plus 2 is 26. 6 times 26 is $156. That's how much money that Jamie will make in a 12-hour shift. All right. I think I've done at least one of each type of problem. Ask questions if you have them. Do the homework. Bye.